Okay, so last week, you remember we talked a lot about evolution. So let's start jogging your memory, and in your own words, what does evolution mean?
Evolution is kind of how species adapt or change over time to adapt to their environments.
Yeah, that's exactly right. So evolution is a change of heritable traits. So heritable traits are the genetics. So species genetics that can be brought to their offspring over successive generations. So important to note here is that this doesn't just happen within one species' lifespan. This happens very gradually over a long period of time. So today we're going to be learning about a specific type of evolution called divergent evolution. So this is the idea that when related species develop very different traits due to their environments or selective pressures. So it's a way to think about this. There's so many different environments. You can live on the land, you can be in the water, you can be in the sky. So for example, let's look at a bat and a human. So at first glance, we have nothing in common with a bat and a human. We're really large, they're in the air, they fly, we have nothing in common. But when you look at this, so this is the wing of a bat, and this is the arm of a human, you'll start to see that we have a lot of similarities. And they're made up of the same components, but they are different, their functions are different. So this idea is called homologous structures. And homologous structures are body parts that develop from the same embryologic tissues, but may have different functions. So here we see, we'll go ahead and circle it, we see that the human has phalanges, and the bat also has them. The human's phalanges, our fingers, are made for writing and articulating and grabbing things and climbing, while a bat's phalanges are more for their wingspan, so that they can fly faster and get further. They're light. So let's see, if you want to come up here, let's see if you can find another homologous structure and circle it in orange. Yeah, that's exactly right. Yeah, so you'll see that there are all different kinds of homologous structures within these two different mammals. So if we continue this, we'll do a different color, and we'll see that there's even more homologous structures. And these, again, homologous structures, are developed by the same embryologic tissue, but they have different functions. So now we need to know, is this just with bats and humans, or is this among all mammals? Is this, are we similar, are structures similar to a horse? Are we similar as cats and dogs? So let's take a look at two other mammals, and you have a worksheet in front of you, and I'll put it on the board. We're gonna look at a cat and a horse. So this is a horse up here, and then this guy is a cat. So I want you to look at these two and determine on your piece of paper, do these have any homologous structures? Do they or do they not? So go ahead and circle on your paper what you think are homologous structures, and I'll do it up on the board, and we'll see if we come up with the same answers. It's different colors, so it's easy. Okay, so I circled a few of them. Let's see if we got the same answers. Does your paper look like this? Yeah, it looks like we got the same answer. Good job. So based on this, we see that different mammals have these similar homologous structures, but they have diverged based on their different environments. So on that, let's think about what mammals we think would be more similar, which one would show more similarities in their skeletal structure, and which ones would show more differences. Do you have any idea?
Probably mammals, animals that live in the same environment would have similar structures, whereas mammals and animals would have like differences if they're in completely different ones. Like you're talking about land and water, land animals. And
Yeah, that's exactly right. Yeah, so mammals have made these adaptations in order to survive in their different environments. And so you'll find that mammals that live in similar environments are going to have the same adaptations. So after all of this, why is divergent evolution even important?
So that animal or mammals can survive in their surroundings, pretty much.
Yeah, that's exactly right. So in order for them to survive in these different environments, they need to be able to adapt. So for instance, a human probably wouldn't make much sense swimming in the ocean all day because we just don't have the same adaptations as, say, a whale does. Although we do have all of these homologous structures, so we have the same components, but we've adapted to our different environments. Okay, so we're running out of time. So tonight, I'd like you to finish up the worksheet that I gave you, and then I challenge you tonight to start thinking about convergent evolution. So we've been thinking about divergent evolution and what that means. So tonight, think about what convergent evolution means, and we'll see you tomorrow.